collection team.
All right. Let me share my screen. Yeah, I think you can see it. Right. Okay. So yeah, we tried to predict. Wait. I can hear myself twice. I think, Julian, you have to mute yourself.
Oh yeah, sorry.
Yeah, no, it's better. Sorry. All right. So we tried to predict the prices of NFTs, and we combined actually two networks. So we tried to combine the visual features with the CNN and also the historical sales data with an RNN. Before that, we did this on the Cryptopunks collection, which is one of the most famous NFT collections, and there are 10,000 unique items in the collection. It launched 2017, and it became an inspiration for the modern crypto art movement, and a part of the cryptocurrency and decentralized finance ecosystem. The highest of the Cryptopunks, or of one item sold, was for $23.7 million in February 2020. So yeah, first, how did we collect the data? There are some data sets on OpenSea where you can get the data via an API. We also did that, so we had the historical data, then the sales data of the NFTs, but we couldn't get the images because on OpenSea there were only like really small images, so we wouldn't be able to train a model on it. So yeah, we searched a bit, and actually on the website where the Cryptopunks are from, you can find the images in good quality and then URL. So we did a for loop and scraped the images then with Selenium, and then with base 64 we encrypted or encoded the images. So we could use them for the models. So the data distributions, there were 6,393 punks sold, and we only took the ones which were sold, so the around 3,700 or 600 which weren't sold, we didn't take into our data set, because there we thought, it wouldn't help with any prediction of time series. Of course, this is a bit biased, but we thought this would be the best solution. Here you can also see that many of them were sold for not that much in Ethereum. So 50% was sold under 24 Ethereum. And here on the right side you can also see the histogram. So there's like a long tail, you could say, where just a few were sold for really much, for example 4,200 Ethereum. Also here in the box plot you can see the outliers. And then of course, besides these values, we also have the image features. And here on the left side we can see a punk. This was the most expensive punk ever sold for $23 million. And we can see that the punks have different attributes. So this, for example, has only one attribute, which is the bandana. And here we can also see how often this appears in the punk collection. And also the alien skin is like only 9 of the 10,000 images have that. So this could be a feature which drives the price, because it's then so much more worth, because nothing is doubled in the image. Yes.
So that's my time about building the data set. So we were first thinking about shall we predict the sales at the item scale? But the thing is, the most item the items that has been sold the most of time has been sold like for less than 15 sales record. It's not enough to plot a time series, and then it doesn't say much because there is a high volatility from one NFT to another, so it doesn't say much about the others items in the collection. So we decided to predict sales at the collection sale. And so we will create time series using the date, the price, and adding the visual feature for each price. So we needed one sale for each day in order to plot a time series. And so because some days you have a few NFTs that are being sold, right? So first we thought about taking the mean but for the price sale, but actually it doesn't make sense to take the mean of images, right? So we switched to median sale. So for each day we took the median price sale and the corresponding image. And the dates aren't continuous neither, because Cryptopunks aren't sold every day. So first we thought about generating fake data for the missing days, but same, it's something we can do for prices, but it does not make a lot of sense for images. So we decided to take the dates like they are, even if there are not sales every day. We can still concatenate it in a regular step and consider that, yeah, our time will be the days where items are being sold. And so after this data transformation, this is what our data set look like. So we have the training set in blue. It rides from 2017 to 2021, let's say, and the test set that's in orange are the last sales from 2021. As we can see with human eyes, there are not so much patterns, right? So it might not be so easy to predict pricing in this condition. But let's say, next slide please. Alright, so that's the whole model architecture. So we are first on the left processing the images through a pre-trained CNN. Then this output will be saved. On the right side, we are processing the simple RNN on date plus prices. Same, the output will be saved, and we concatenate both CNN and RNN outputs to pass it through a final model, which is a CNN 4x series, actually very similar to the last one we've seen in the course. What I can tell you about the pre-trained CNN model is using the ways from ImageNet. ImageNet is a very popular, let's say, image classification data set. So we are importing these ways. And in the simple RNN, we are using batch normalization, which helped a lot to achieve some good results. Next slide, please. So now there is a bit more of details about the CNN and the RNN, the two preliminary models. As you can see, so we are using the pre-trained VJJ16 CNN model with an input shape of 64 times 64 times 3 for the images. The original images were 336 times 336 pixels. That was way too long for processing. I think the computer crashed a bit. So yeah, we downsized the images to 64 times 64. And as you can see, we are adding some layers, output layers to the pre-trained VJJ16, since we are not in the context of image classification but visual feature extraction. So we end up with two layers that are outputting 4096 features for each image. That's something we are using the same loss and optimizer and metrics for the three models. So then at the end we can compare it more easily. And you can see the RNN. I would say it's a simple RNN model, but with batch normalization after each layer. Next slide, and it will be CAN.
Thanks. So for the final slide, can you hear me?
Yes.
Yeah.
Okay, for the last slide, the input will be the CNN output. This is from the visual extraction, and combined with the RNN output, that is the time series prices or the sales. And then we put into, we use the convolution 1D and also the LSTM for doing the final model. And the final combined with the same loss and matrix that we use. The loss for the mean square error, and the matrix is the mean absolute error. And we apply for the Adams law with the learning rates for this one. And next slide, please. And then we have the model on the upper left-hand side is the history CNN. So this is our first trial, and as you see, after 40 epochs, we observe the first interception, and we believe that after maybe when we train more epochs, we can get the better results. And but still, the loss are very big. Because we base on the median of the sales data. And for the upper right-hand side is the normalization process, and it seems pretty good with the loss close to zero. And the history RNN, as you see, this is a time series we achieve also. The trend seems quite good. But we still have the very high loss with the real, and then I do the improvement by taking the log of the sales data, and it's much better, but it's still big. And for the history final model, as you see that we have the train and test set quite okay with us. But we believe that we can improve more. And next slide, please. So what's next? Are we thinking about add more predictors to the input data? For example, the rates from the Bitcoin or the stock markets. That's also high for community engagement, because we think that the more data that we have, we can get more features to add in the images or the prices to improve our model. And still we are thinking about the training time, because we get so many crosses during the training dataset, training data. So we need to do more experiments about the learning rate, probably decrease a little bit to get faster training and train more e-books. And that's our presentation. And thanks for your help.
Perfect. Thanks a lot. As always, now's the time for questions and